First, the equation asks us to, or the problem asks us to determine if the yield from the equation is exothermic or endothermic. So we're given 2,220 kilojoules as the answer. And because of this negative here, it tells us that it's exothermic. Because the products are less than the it shows that the products are less than the reactants because the reaction releases energy, which means it's exothermic. For question 2, we have 250 grams of water and it is heated over a canister that contains 4.5 grams of protein. The temperature of the water increases from 65 degrees Celsius to 70.8 degrees Celsius. The mass of the propane tank after heating has a mass of 4.38 grams. Calculate the fuel value in kilojoules per gram of propane. So first we need to figure out the heat that it is creating. So we will use this equation, so heat equals the mass times the specific heat capacity times the change in temperature. So we're given that the mass is 250 grams for the water. The specific heat capacity of propane is 1,680 joules per gram. And the change in temperature, we have to convert them to joules first. Or not joules, kelvins. So we take 65 degrees Celsius plus 273 to get 338 Kelvin. And then we take 70.8 plus 273 equals 343.8 Kelvin. And then you subtract the T final minus the T initial to get 5.8 Kelvin. So the change in temperature is 5.8 Kelvin. Then we put it into the equation. Q equals 250 grams times 1,680 joules times 5.8 gets you that long number in joules. So for the next part, we're going to have to convert that into kilojoules because that's what the question's asking us to give it in kilojoules per gram. So that would be the first step. So 2436000 times the conversion factor from joules to kilojoules. So we need to have, this is in joules, so we need to cancel out the joules on the bottom, and 1,000 joules is equal to 1 kilojoule. So then we get 2,436 kilojoules. So now we're given the two numbers, 4.5, the starting of 4.5 grams, and the ending of 4.38 grams. So we want to see how many grams we've lost that created that much energy. So we lost 0.12 grams of propane. So then we take this Q number, which is 2,436 kilojoules, divided by the 0.12 grams, and that will give us the kilojoules per gram. So 2,436 divided by 0.12 gets us 20300 kilojoules per gram of propane. The next step is to calculate the heat that would be generated if 155 grams of propane combust with unlimited oxygen. So we're given the 155 grams, and then we first need to convert that into the molar mass, or the molar number to be able to convert it into energy. So 1 mole of propane is 44.097 grams. Oops, and that's moles, because we want to cancel out the grams on the bottom to leave us with, I didn't do that math yet, 155, and then it's going to be divided by 44.097 grams, gets you, we'll do 3 sig figs because that's what we're given, 3.51 moles of propane. So once we're given that number, we can convert it to energy, which is 2,220 kilojoules per mole, per 1 mole of propane. So those moles cancel out, multiply across, 3.51 times 2,220 gets you 7,792.2 kilojoules. Okay. And then for part 4, we're asked to calculate the moles of carbon dioxide produced from this equation. So we have the 155 grams of propane times 1 mole, we need to convert it into moles again, so 1 mole over 44.097, which we know is 3.51 moles of propane. And then we take that, so that's the molar mass, and then we need to use the molar ratio to convert that to carbon dioxide. So on the bottom, we do the moles of propane. So we can see in the equation here that there is 3 moles of CO2 for 1 mole of propane. So the 1 mole of propane goes on the bottom, and 3 moles of CO2 goes on the top. So after that math, we are given 10.5 moles of CO2 for 155 grams of propane. Okay. So now, if the reaction occurred at a pressure of 1, so let's write these different numbers down, of the ATM of 1.05, the temperature of 1,980 degrees Celsius, calculate the volume of CO2 produced. Okay, so we're going to look at the ideal gas law to find this conversion. Because we are trying to solve for volume, which we don't have a number for. So, but we also have the amount of gas. We have that there is 10.5 moles. So if we look at the equation for the ideal gas law, we need the pressure, which we have, is 1.05 times the volume. We don't have that. That's what we're looking for. Equals N. We have that with the 10.5 moles times R, which is a given, times the temperature, which is 1,980 degrees Celsius. But we do need to convert that to kelvins. So once again, we just add 273, 1980 plus 273 is 2,253 Kelvin. Okay, so let's just plug it into the, well, actually first we want to change this equation to be, to solve for what we need it to solve for. So all we have to do is divide both sides by P. So we're left with volume equals N times R times T over P. So let's plug in our values that we know now. So V equals the N, which is 10.5 moles, times R, which R is usually 0.0821. And then multiply it by the temperature, 2,253 Kelvin, over the pressure, which is 1.05 atm. So then we just solve that. 10.5 times 0.0821 times 2,253. And then we take that number divided by 1.05. And we're left with, well, we need to round it to 3 sig figs. So 1,850 would be the rounded to 3 sig figs. So that is our volume. In grams, because that's what we've been using. Okay, so now the last question asks us, the CO2 produced in the reaction is collected and cooled in a room at 27 degrees Celsius and at a constant pressure. Calculate the new volume of gas. So for this, we want to look at Kelvin's law, or Charles' law, sorry, because we are looking at temperature, we're given temperature and volume. So Charles' law is V1 over T1 is equal to the V2 over T2. So we know now that the volume is 1,850 grams over the T1 is 1,980. Oops, nope, it needs to be in Kelvin. So Kelvin, we did 2,253 Kelvin. And then we need to convert this to Kelvin, so plus 273, 27 plus 73 is 300 Kelvin. So we're given 300 Kelvin over the unknown volume. So then we multiply by 300 on each side to cancel that out, and then you get 300 times that. So now we just solve 300 times 1850, and then divided by 2253. And we get a volume of 246. Because we'll do 3 sig figs. So 246 grams. All right, and that's it.